Chain rule with tangent. So find f prime of x given f of x equals tangent cubed of 3x squared plus 1. Ooh, that's a lot of nesting. Ooh, baby blue. Or is it cyan? I think it's cyan. Okay. So, yep, this is going to be the chain rule. So the chain rule is f of g of x equals f prime of g of x times g prime of x. You'll see this written in different ways, and there's basically different ways of looking at the same thing. For the AP Calculus exam, I think this is probably the best way to look at the chain rule. Sometimes you'll see F circle G or something like that. This is the way I like to write it. And for this class, I think it's easiest. Okay. So for us, we'll say that f of x equals tangent cubed of x. So then f prime of x, this will again be another chain rule. So we'll do 3 tangent squared of x times secant squared of x. So the derivative of tangent of x is secant squared of x. That's something you pretty much just have to memorize. You should know sine of x, cosine of x, and tangent of x. And then this is using the chain rule. If for some reason you had a significant amount of time and you forgot what the derivative of tangent of x was, you could figure it out on your own. You know that tangent of x equals sine of x over cosine of x, which you could then rewrite as sine of x cosine to the negative 1 of x, and then you could just do the product rule for it. And with enough time and work and effort, you'd finally get to secant squared of x. But it's used commonly enough, and it's so much work. Not so much work. It's a reasonable amount of work to find out what the derivative tangent of x is, so that if you can memorize it and bypass the work, you're better off in life. Okay, so we got the f part. G of x, that's the interior. It was 3x squared plus 1. 3x squared plus 1. G prime of x equals 6x. Because you take the 2, multiply by 3, the x to the second goes to x to the first, which is x. And then the constant, the 1, just disappears. And now we put it all together. So f prime is 3 tangent squared of x, but we want to put in g of x here. So this will be 3x squared plus 1 times g prime of x, which is 6x, times secant squared of x, secant squared of 3x squared plus 1. This part should probably actually be over there. Yep. Then I'm going to rewrite this so that this is a little bit more legible? I don't know. Because my handwriting is pretty bad. So we'll say 18x tangent squared 3x squared plus 1 times secant squared 3x squared plus 1. See if that's a 18 tangent squared secant squared. Yep. It even looks, yep. So it'll be this guy right there. The top one. Yep. 18 times tangent squared. So if you're going to work with this more, like do some other operations with it, one thing you might want to consider then is tangent is sine over cosine, and secant is 1 over cosine. So I guess these would both be squared. And you might want to convert it to sines and cosines. That way, I think it's just easier to work with just sines and cosines than secants, cosecants, tangents, cotangents. Sometimes it simplifies things. Okay, that is how you do this with the chain rule. Usually I don't go through this level of formality with the chain rule, But for this problem, it might be worth it because you have to use the chain rule like 2 or 3 times because you have this function in here, and then you have the cubed involved. And adding a little bit of formality to it for this problem might be worth it. But if you're comfortable just doing the chain rule with multiple iterations in your head, more power to you.